3D was conceived among the larger Wipro group in 2012. So we're about 12 years old, 12 and a half. And we have been in the space of 3D printing all this while. We started off with 3D printing for metal technologies, and we can 3D print a whole lot of materials, which I will discuss. So we as Wipro 3D belong to the larger umbrella of Wipro Infrastructure Engineering, which then falls under Wipro Enterprises. So this is where we come in into the whole Wipro family. And we have been working with aerospace and space sector for all these years extensively. The first part that you see on the left bottom is a metal 3D printed part. It's called a feed cluster. And this is India's first metal printed part, which went out in space. It's still orbiting our Earth on GSAT 19. And we're very proud, and we say it with a lot of pride, that we have 3D printed this here in Bangalore at Wipro 3D. If you notice the design, it looks very different from what can be achieved through conventional manufacturing. And we have a special term for that. We say that this is DFAMD, Design for Additive Manufacturing. So it's a manufacturing process that allows a lot of advantages, opens up a lot of new doors to designers, especially to offer lightweighting, which is a very critical value addition to both the aerospace and the space industry. The one part that you see in the middle is called the inner ring, and this is certified by Semilac, which we supply to HAL. The last part that you see on the right bottom, this is the PS4 combustor, and this is our most recent achievement in terms of 3D printing for space. And yes, again, it's been designed so that a lot of multiple parts have been integrated to make this one component. I will speak a bit more about the design. At Wipro 3D, we do print services both in metal and polymer. We can offer machines, 3D printers, if you would wish to print on your own, or set up the entire lab for you or center of excellence. So this we call as turnkey solutions. We also conduct a lot of training and consulting. We are extensively certified. We have NADCAP, which is for special processes, AS 9100, which is especially for space and aerospace. Here are a few parts, and it says a lot, but what I want to draw your attention to is the complexity of the parts that can be achieved. They are complex, but they are very lightweight as well. And there are a host of different materials over here. Some of them are aluminium, some of them are steel, and some other are Inconel 718. So we have a whole range of materials. And when we come to lightweighting, in additive manufacturing, you could achieve lightweighting in two ways. First is the design, like I showed you previously. It's possible to have complex designs and just put material, as the name says, additive manufacturing. So add material only where we need the material to be, as against a subtractive manufacturing, right? So through design, the part becomes lighter, but material selection is another leverage that we have to do the lightweighting as well. So the speakers before me spoke about titanium and aluminium. So yes, we can do both of them. At this point of time, I also want to tell that tooling is something that we can do as well. And you saw the tooling with, those channels where the coolants can flow inside. So these channels inside the tooling could be made conformal, could be made very complex, so as to take the heat away very quickly. So these kind of complex inner channels, just imagine it to be in the shape of a spring or in the shape of S. So these are things that can be achieved through additive manufacturing in one piece, no leakage, no cross drilling. We also offer polymer printing services, and we have 3 different technologies. And when it comes to composite manufacturing, these are some of the technologies that we could use to process composites. It's quite common to have carbon fiber reinforced nylon or other polymers. It's also possible to have glass fiber with polymer as composites, but metal ceramic composite is also something that is possible in additive manufacturing. So the process gives you the power to use these kind of composites. This is our own FFF 3D printer. This is a printer that we make. So till now I spoke about the services. This is a product that we can offer. And this, we have a tie-up with Nikon SLM, and we can also provide metal 3D printers. This is our training and consulting slide. So we do a lot of training and consulting if you are interested. But that is what I wanted to share. Right? So I'm going to stop sharing and also talk about composites and ceramics like I was telling you. Though we started off with metal 3D printing, what we do today is catering to our customers in full, whatever may be their demand. So it could be metal, it could be polymer, it could be ceramic, whatever is the requirement. We have the partner ecosystem, or we've set up ecosystem where we can cater. Not only just printing, when customers come to us, they are looking for a complete solution, meaning that after printing process, we will have to do some machining, we'll have to do some polishing. All of this is what we offer to achieve the customer satisfaction and to provide for it. So design materials, I have spoken about both of them, but I want to speak a bit about the metal printing landscape. There are a few technologies with which we can print with metal. One of the most mature technologies available in the market, and this is through industry standards, the most mature technology to print with metal is called as LPBF, laser powder bed fusion. And it uses powder as the raw material. We have a plate or a bed or a platform on which you spread powder, and you could use either a laser or an electron beam to melt this powder. It solidifies immediately, layer by layer, and then we have the complete part. So this is the most mature. Why do we say it is most mature? Because it's been in use for a long time. We have a good amount of data material-wise to say and understand how the material is going to behave and how to control it. Most of the certified parts for aerospace and space come through this technology. However, there are other technologies to print with metal, and one such category, according to ASTM standards, is called DED, Directed Energy Deposition. Over here, we have the raw material in form of wire, or it could be in form of powder. We have an energy source which is directed towards this raw material, and then the material is melted, deposited. DD technology can be used to make really, really large parts. Just to give you an idea of how large it could be, an entire bridge across a canal in Amsterdam has been 3D printed in just 2 parts and assembled. So that's how big it can be. The parts can be really, really small as well. So there are some other technologies with which we can print metal. One of them is also material extrusion, predominantly used for composites and polymers. But yes, metal is possible even through that technology, a bit through SLS or variations of the, SLA process and variations of the SLA process. So out of the 7 technologies that are listed under the ASTM category, 5 of them are capable of printing metal. And out of these 5, we have to understand that each of them has their own limitation and their capabilities. And we have to find the right technology based on the application. Nothing like one technology is better than the other. They all have different capabilities, and we can choose the right technology based on what the application is.